Let's look at arithmetic sequences. Let's say we have this sequence. Now, we can notice a pattern. The next number is always 3 more than the first number. So, 7 minus 4 is 3, 10 minus 7 is 3, and so on. By using this logic, we can find these two numbers. So, if we add 3 to 10, 13. If we add 3 to 13, we get 16. Now we can verify that these are right because 16 plus 3 is 19. Now, what if we had a larger sequence? We couldn't have just added all the 3's over and over and over and over. If we had 1,000 digits in the sequence, we'd have to have added 3 1,000 times. Let's try and find a formula. So, let's just say we never knew these two numbers. How would we have gone about finding them? Without using these 3's, we would have had to use the first number, and we would have had to use the difference, which is 3. So, the number we want to find is the fifth number. So, the fifth number will be the first number, so that's 1, plus, we're going to add 4 of these 3's. So, this will be 1 plus 12, which is 13. Now, we know this is correct, because 10 plus 3 is 13. But how can we relate this to a formula? So we can say that the number we want to find, which we can call the nth number, is the first number, so that's 1. So we'll call the first number A, plus, how did we get the 4? The 4 is just 1 minus the 5. So we can say n minus 1 times the 3. We can call the 3 the difference, so we can denote that with the d. So this is the formula. Now, this formula should be intuitive. Let's try this formula to find the sixth number. So the sixth number, as we know, is 16. But will it work with this formula? So the sixth number will be the first number, so that's 1, plus 6 minus 1, so that's 5, times 3. This is 1 plus 15, which is 16. The formula works. Let's try it for another sequence. Let's say we have the following sequence. We already know the first 3 numbers. Now we can find the difference by subtracting 19 by 6. That's 13. 32 minus 19 is also 13. To find the fourth number, we could just add 13 to 32. But let's try using the formula. So the fourth number will be the first number, so that's 6, plus 4 minus 1, so it's 3, times 13. This is 6 plus 39. This is 45. So we know the next number is a 45. Let's say we wanted to find the fifth number. The fifth number is 6 plus 4 times 13. This is 6 plus 52, which is 58. So we know the next number. So you have a decent idea of finding the nth number. But let's say we wanted to add the whole sequence together. So this was the full sequence. Let's say we wanted to add all of these together. It would be a lot of work to individually add each of these together. 6 plus 9 is 25, plus 32, plus 45, and so on. So there has to be a formula. The formula is n divided by 2 times 2a plus n minus 1 times d. Now, n divided by 2 is the number of terms in the whole sequence divided by 2. 2a is 2 times the first digit, and n minus 1 is the number of terms minus 1, and d is the difference. So let's plug all the values in. We know the sequence has 8 numbers, so we can plug in 8 over 2, then 2 times the first number is a 6, plus n minus 1, so that's 8 minus 1, times 13. This will be 4 times 12 plus 7 times 13. This will be 4 times 12 plus 91. This will be 4 times 103. This will be 412. So the sum of all of these combined is 412. Using the formula is much faster than doing this by hand by adding each of these together. Now, arithmetic sequences can be a little bit tricky, so this requires a lot of practice. I've linked a practice worksheet and its answers in the comment section, so make sure to go check those out.